Alright, so I'm going to be working through problem number 6 in chapter 37. The problem goes, as you pilot your space utility vehicle at a constant speed toward the moon, a race pilot flies past you in your space car at a constant speed of 0.800 c relative to you. At the instant the space racer passes you, both of you start timers at 0. Part A. At the instant when you measure that the space racer has traveled 1.20 times 10 to the 8th meters past you, what does the race pilot read on her timer? So we can solve this using our Lorentz transformation for position, which is equal to gamma times x prime plus u t prime. See. Alright, so now we just plug in the values that are given to us, and we are solving for t prime. Alright, so this is just going to go to 0 because there's no position she's really measuring from her reference frame, at least yet. And this position is, see, put that in a second. So if that just goes to 0, then we just have x equals gamma times ut prime. So then we just divide these two over, so then it's x over gamma u equals t prime. Then we just plug in our values, so that just comes out to be, so if we were to expand this a little bit, 1 minus u squared over c squared all over u equals t prime, the time in her reference frame. And so if we were to just plug in the values given to us, so x was given to us to be 1.20 times 10 to the 8th meters, so we plug that in there. And then we plug in u, which is also given to us. U is her speed, and that is 0.00 c, so we plug in that and the speed of light. And if we were to evaluate all this and keep track of sig figs, the time that she measures comes out to be 0.300 seconds. It's the time that she measures. Alright, time for part B. When the race pilot reads the value calculated in part A on her timer, what does she measure to be your distance from her? Okay, so let's see. So when you measure the space, what does the race pilot read on her timer? When the race pilot reads the value calculated in part A on her timer, what does she measure to be your distance from her? So then we can solve this by looking at the distance. So the distance from start to here, here's the pilot, here's us. Start, that distance is 1.20 times 10 to the 8 meters. And so then if we know the time she measures and we know her velocity, we can just, actually this part's not even, I don't think the part's even, if we know her time that she measures and her velocity, we just multiply that time by the velocity that's given. So 3.00 seconds, of course a bit longer because you want to be a bit more exact, so you want to use the value that you actually calculated, not the sig fig value, you want to expand it a bit more. So it's the time that she measures multiplied